Hi guys, I hope you are doing well. Continuing CCNA Labs series, today I would like to cover step to configure the OSPF Cisco router. The first of all, let's talk about topology. As you see, today I had the six router connect each other, and I'm going to configure the OSPF using error 0 on the router, and I set up the router ID, follow the format 11.1.1. Router ordering. If the router sys, so the router ID is 11.1.1.sys, and process ID is 1. And the link between router 2 and router 3, I'm use network to boy the special network type. This type the routers will not elect the DR and BDR, and I'm using the OSPF version 2 on the on router. By the way, in the previous video I had wrong explanation. OSPF version 2 router cannot install it adjacency to OSPF version 3 router. Okay, this is my mistake, and I set up the 3 loopback on router 1 and 2 loopback in router 5, so I need advertise them to the each router and then check connectivity between router 1 to router 5 using the source is the loopback IP array. Okay, to save time, I set up the IP interface IP array for each router already. So now let me open the console and configure the OSPF configuration. First, let me open the wireshark on the switch box 01 to verify the OSPF message between router 1, router 2, and router switch. Okay, capture 1. Okay, so I need to go to the configuration mode and using the command router OSPF. We had the two version 2 and version 3. I use version 2, so I join the OSPF and follow the process ID, process 1. And under the router OSPF, I need to define router ID, and 1111 and router 1 is so router 1. And the next step, I need enable the interface, the with interface join to the OSPF domain. There are two ways. The first, I use network keyword and follow the network number, and my network number ID is 10.10.10 and /29, right? So the network ID is 0 and follow is the wireshark marks. Wireshark mark is invert version of subnet mark. I also not here subnet mark 29, so the wireshark mark is 0007. Okay, 0007 and follow is area and area ID. Okay, right after I enter this command, the router will check the active interface. If the IP of interface match the network ID here, the interface will join to the OSPF and router send the bucket hello bucket out the interface. Okay, check the message. This one, right? OSPF send hello bucket out interface 10.10.10 1. Okay, and the second way is use the IP OSPF under the interface. With interface we want to enable OSPF. In my case, interface 0, right? So 0, so I use command IP OSPF, follow the OSPF process ID, and then define the area, then the area 0. Okay. Okay, similar the router 2. Router 1, I config router OSPF and process ID 1, and define a router ID 11112, and to enable the interface I will use option 2 using the IP OSPF process ID and area under the interface mode. So my interface in router 2 is 0. Okay, so IP OSPF, okay, process ID 1 and follow the area, okay, 0. Right after I enter, the router 2 will send the packet out interface 0. Okay, let me check. Okay, now on the bucket sent from router 1, right? So I enable on router 2. Yeah, you see router 2 send the hello bucket out. Okay, and okay, similar into the router 6, go to the configuration mode using router OSPF 1 and router ID 1111 and sit using the OSPF under the interface. So go to interface and using IP OSPF 1 area 0. Okay, and router, okay, hello bucket from router 6 1. Okay, so let me analyze the wireshark in detail. Okay, the first packet sent from router 1, right? Okay, let's see. We had source router ID 11111. Okay, and in the hello bucket we had destination router and backup designated router is 0, because now router 1 don't know the designated and backup designated. Okay, in the NAC hello same, right? In NAC hello same, and you see in the broadcast network type the router will send hello message every 10 seconds from the second 146 to 156 10 seconds, right? Okay, so and in this hello bucket router 1 elect each shell is a designated router, because in case during the 40 seconds the router will if the router did not receive any hello bucket from another router, it will think it's a designated router. Okay, and don't have the backup designated router. Okay, we had the hello message from router 2, and now you see designated and backup designated 0, right? And go to the next. Okay, next hello message from router 1. We see now router 1 see the router 2, right? So the two-way is complete, and go to the next stage is turn agent, right? In this stage router will elect the master and slave to handle the database decryption agent. So go to database decryption, we check. Okay, send from router 2 to router 1 and router 2 to elect it as master, and one database bucket from router 1. Okay, router 1 also think is the master, and after receive on database description, the two router will negotiate slide and master. And so in the next kit sent from router 1, we see router 1 now is a master, it means it's a slave. And automatically from router 2 is the master, and after that two router will request the link state update using request and update, and after that it needs send the link state knowledge for each link state update. Okay, after that enable the OSPF in router 3. So router will send hello packet, but in the hello message this one, you see now router 2 agree router 1 is a designated router and this is a backup designated router. Even router 2 had higher router ID higher than router 1. This is the non-preempt in the DR and BDR election OSPF. Okay, even router because when router 2 join to OSPF, it see the DR, so it will not trigger the DR and BDR election again. So we see the router 1 also still is designated router, and the backup designated router is router 2. Similar router 6. After I enable the OSPF, router 6 join to the OSPF domain and send hello packet with non-DR and BDR. Okay, but after router 1 receive the hello message from router 6, it know router 6 and router 2. Okay, but the designated router is same, right? Router 1 and router 2. Let's check the hello message from router 3, this one. Okay, 10.10.3 is now router 6 agree router 1 is designated router and router 2 is backup designated router. This is a non-preempt in the DR and BDR election or ABS. Okay, so now I will configure one more interface on router 2, router 6, and then do the another router. Okay, in router 2 I go to interface 01 and enable the OSPF 1 area 0, and router 6 we have the two interface, right? So I use interface range 1 and 2. I see IP OSPF network, sorry, 1 area 0, and router 3 go to config mod router OSPF 1, default router ID 11113, and I had the three interface 0, 1 and 2. So using the range keyword interface range 0 and 3 and enable the OSPF 1 and area 0. Okay, let me check the interface. So IP interface bridge, do so IP interface bridge. Okay, because interface 3 shut down and no IP, so the router send the alarm to me, this one. OSPF will not operate on this interface until the IP configure on it. Okay, it's okay, doesn't matter, right? Okay, and go to router 4, same, right? Router OSPF 1 and router ID 10 4. Alright, and using the interface range and 2, so IP OSPF error 1 error 0. Okay, so with interface range we can configure multiple interface at the same time, very easy, right? So I always refer this configuration in practice. Okay, final router 5 and config router OSPF 1 router I. Okay, in this router I did not define the router ID, just enable the interface. Okay, so interface 1 and 1 range and IP OSPF 1 error 0. Okay, and wait a second. Okay, let's check the router. So IP OSPF enable in router 4, and you see router 4 has the router set and router 5 neighbor. Okay, our router 5, so IP OSPF neighbor. Okay, and neighbor is router 3 and router 4. Maybe let me check the router one more time. Those so run OSPF. Okay, I'm wrong. Maybe it's the old configuration. So let me delete router OSPF on router 5 and okay, so run one more time. Okay, now right, router OSPF 1 and okay, server interface 3 do so run. Okay, so I need to enable in OSPF interface 0 and 1. I ran IP OSPF 1 error 0. Okay, so let's check neighbor. Okay, you see if I did not define router ID under the router OSPF mode, the router will take the will use the loopback, the high loopback IP address. In my case is loopback 0 on router 5. So router 4 see the neighbor is IP of loopback 1 in router 5. This is router ID. Okay, so IP interface grip. Okay, loopback 1 172.19.2.1. Okay. Okay, one more thing I want to discuss is the DR and BDR in this network. Because router DR and BDR is as a non-brand, so in case one I would like to the set is the DR of this the network segment. I need clear the router OSPF process on router, and after clear the IP OSPF process, the router in the network segment will trigger the DR and BDR election. Okay, command is clear router, clear IP OSPF process 1 reset and confirm yes, and same line in router 2 clear IP OSPF reset yes, and router sit clear router OSPF clear IP OSPF reset and yes. Okay, and I would like to show IP OSPF neighbor and my implementation router sits in the DR of this network segment. Okay, so not yet, right? Two-way. Okay. Okay, now DR BDR complete. So router 1 is a DR author and router 2 is BDR, correct, right? So router set is BDR. Okay, and so IP web neighbor and router set is DR on the subnet. Okay, and router 1 is BDR. Okay, so 1. Okay, this is a height router ID. So after clear the process, router set is the DR, correct, right? Okay, and now I need to come back to router 1 and advertise the Labs interface. Labs interface, this one. Okay, and because Labs interface is a connected IP, so there are two ways to advertise this those subnets. One is redistribute, and second is just enable the OSPF in the Labs interface. Enable OSPF is simple, more simple than the redistribute, so I will choose this ways, and I will use the interface range 0 and 2. Then using IP OSPF 1 area 0 and go to the router file and check whether so IP routing table router 1 router file receive the Labs receive, right? This one 192.168.1.1, but you see my Labs set mark is 24, but router file receive is 32. So to resolve this, I need using command IP OSPF network boy to boy. Okay, and now router file you receive the Labs with the set mark 24. Okay, correct. Reason why I would like to I will explain in the next video when we understand how to configure basic configuration of OSPFs. Okay, in router file I also had to Labs need be advertised, so interface range 0 and 1. Okay, so using IP OSPF 1 area 0 and using IP OSPF network boy to boy, and check the routing table on router 1. So IP route, and we see we have the two subnet, right? And select 24. Okay, correct. Okay, now let's try ping from router 1 to the 172.19.1.1 and which works Labs 0. Okay, can ping, right? Okay, 2 can, and one can. Okay, sending router 5 and ping 2.168.1.1 and so 0 can, right? Can. Okay, how about the 2.1? Okay, can. So connectivity, connectivity between router 1 and router 5 now is working. And one more thing I would like to discuss is the metric. Okay, it's how the router OSPF calculate the metric in my lab. Okay, in previous video we discussed the OSPF calculate the metric using the logic, the total cost of outgoing interface from source to destination, right? The code interface has the formula, right? So in my labs, for example, from router 1 to router 5, I need calculate total cost from outgoing interface, the interface, the interface, the interface. Okay, so to verify the code of interface, I use so IP or OSPF interface brief, and I see interface 0. This one has the code is 10, and you see the loopback also has the code is 1. Okay, so this box has the code is 10. Okay, and let's check in router 2. The 2. Okay, 1, and so IP or OSPF interface brief. Okay, so box 1 also has got 10, right? 10, and router 3 box 1 also. So IP or OSPF's interface brief. Okay, box 1 10. Okay, 10. So we have to code it 10 10 10 30, right? But the router calculate it 31. So 31 goes in the router 5. We had the loopback interface, so the router thinks traffic go to loopback also in the incoming traffic. So also had the metric. So we had the traffic go to the loopback, also had the traffic 1. So total cost is 10 10 10 and 1 is 31. Correct, right? Okay, how about route in the router 3? Okay, router 3. Okay, router 3, so IP route. Okay, route we had the metric to subnet 1.1 192.168.1.1 average 20. From here we had need calculate metric of the interface and the interface and the loopback interface. So 10, right? 10 and the 10, so total is 20, right? 20 and plus 1 is 21. Okay, how about the metric to the loopback in the router 5? This one. Okay, so we had a lot of path, right? But the router choose this path go to the port 1. Okay, so metric is 10, right? Plus the loopback metric, so total is 11. How about this path? Router I did not choose because metric is 10. Metric is 10. Okay, 10. So total metric is 10 10 10 and plus 1 is 31. So it's high metric than this path, so router did not choose. Okay, clear, right? Okay, now I will change the network type between router 2 and router 3 is voice to voice. So I need go to the interface 0 01, okay, 01 1 01, sorry, 01, and set up the interface, the boy-to-boy interface, so using IP OSPF network boy-to-boy, and you see after I type the command, the router inform me receive hello but mismatch network type mismatch. So I need to go to the router 3 and interface 0. So IP network OSPF network boy to boy, and now neighbor between router 2 and router 3 start loading to full, loading done. Okay, now and so IP OSPF neighbor, and you see neighbor to router 3 on the router 2 we have stay full, but the two router will not start the DR and BDR election, so we had the minus stay here. Okay, same like in router 3, so IP OSPF neighbor. Okay, same right, router 2 stay full, but no need the DR and BDR relation. Okay, I think config the OSPFs the router Cisco it's not complexity. We just need careful about the router ID and how the router calculate the matrix. Okay, thank you for watching, and I see you in that video. Bye bye.